Welcome to the CCTT Training webcast on MPTL versus Modified Single Connector Permanent Link. My name is Mike Panaki. I'm owner of Network Protocol Specialist here in Seattle, Washington. And one of the things that I've found is that oftentimes we don't have enough time in class to cover some of the things that I think are really important in the depth that I'd like to cover them. We've got a lot of things to cover in class. So what I'd like to do today is go through and just take a look at a few things as far as MPTL goes and Modified Single Connector Permanent Link. And one of the reasons I bring this up is that I have had a number of occasions where people have called me after class and said, Mike, I'm out working on a job and I'm stuck. Can you help me out? And so this is pretty much what I tell them. And we're going to go into depth. We're going to take a look. We're going to set some tests up on the Versiv. This is not a slide intensive presentation. In fact, a lot of this is going to be demonstrations and things like that. However, we are going to take a look at one slide up here, or two slides. And that is, I want to take a minute and talk about MPTL versus Modified Single Connector Permanent Link. And let's start with Modified Single Connector Permanent Link. What is it? Well, it is a case where I've got a patch panel on one end, and I've got an RJ45 plug on the other end. Now, in this case, what we find is that we need to be able to test this link. Now, one of the things I'm going to do that I forgot to do before we got started is I am going to make sure that we can turn on chat here in this webinar. If you have any questions, there is a Q&A window and there is a chat window. So if you'd like to ask any questions, I highly encourage those. Please take advantage of that chat window or the Q&A window. So I've got this link, and I've got a patch panel on one end, and I've got an RJ45 plug on the other. Well, we need to be able to test it, and we wanted, the idea was, how could we test this with the equipment that comes as part of the Fluke Networks DSX CableAnalyzer kit? So let me come over here to the rack. I'm going to grab a permanent link adapter. And so what comes in the kit, we get a couple of permanent link adapters. We get a couple of channel adapters. Now, there's something that's important to remember about the channel adapter. And that is, with the channel adapter, the RJ45 plug that's plugged into the channel adapter, we do not include the near end crosstalk for that plug in the test measurement. Well, that seems pretty important. Now, for a channel test, that near-end crosstalk isn't required. However, in this case, if we want to be able to evaluate the quality of that connection right there, we need to be able to measure the near-end crosstalk and return loss for that plug right there. So in this example, this is what's known as a Bixby test. So this is a Bixby specification. Now, this isn't recognized by any standards bodies like TIA or ISO IEC. This is a Bixby test. Now, in this case, what we find is that we've got our test. We can test the RJ45 jack in this patch panel. We can test this cable, but we're not testing that RJ45 plug right there. Now, I am a big one on demonstrating things. So what I'm going to do is I'm going to stop sharing my screen for a moment, and we're going to come over here to the bench, which, oh, that is a bummer. Hang on. You may see a brief interruption in Zoom, or maybe not. But one of the things, I was connected to the wrong network, so I couldn't change my cameras. But we're going to come over here, and we're going to switch our cameras. So in this case, let me move this permanent link adapter out of the way real quick. What I want to show you to start with is here, I have a poorly made modular plug terminated link. I've got an RJ45 jack on one end, and I've got an RJ45 plug on the other end. Now, what we see is that this was not terminated very well. That's could be problematic. So we're going to go in and we're going to test this link using the MPTL, or the Modified Single Connector Permanent Link Test. We're going to use the channel adapter right here on the remote to run our test. So I'm going to take and I'm going to connect this to the channel adapter on this end. And I'm going to grab my permanent link adapter right here. I'm going to connect that up to that RJ45 jack on the other end. Okay. Now, I'm going to share my screen. And I'm going to share my Versive, which I need to reconnect to. There we go. So here I've got my Versive. Let me just move a couple things around here. We're going to create a new project. So I'm going to come into Project. I'm going to go to Change Project. I'm going to say New Project. And we're going to call this MPTL V mod connector. So we'll just give it a name there. I'll say done. So now I've got this brand new project. The next step is I come in and I select the test I'm running. I'm going to select a cable type of Cat6, UTP. I'm going to come down here and I'm going to go to my test limit. Now, right now, this is set to Cat6A permanent link. Now, if I tried to run this test right now, it's going to give me an error. In fact, let me show you. I'm going to go ahead and hit save. And I'll come back out to my home screen. I'm going to hit test. Now, what this does is it comes up and it says the adapter on the remote tester is not compatible with the current reference or selected limit. Well, that's because I chose a permanent link test, which expects a permanent link adapter on both ends. Now, a lot of times people will go in and they'll just say, yes, I'd like to continue. And they will run the test. Now, this is not a valid test. You're using the wrong adapters. Okay, we see, possible bad patch cord at remote. All right, well, let's go in and let's fix that. So I'm going to come in here. I'm going to edit that test. And I'm going to change my test limit. So if all I had was a channel adapter to use with doing this test, what I would do is I would come into my test limit, I would go to More, I would go to Application. This modified single connector permanent link test is an application test. So I will scroll down through my list of tests and I will find my modified single connector permanent link test. Okay. Now I could even run this and test to make sure PoE is going to work. Why not? Oftentimes we're using PoE with these types of connections. So now what we're expecting for our modified single connector permanent link is that on the main, we'll have our permanent link adapter, and on our remote, we'll have our channel adapter. And I'll go ahead and hit save. I'll say use selected, and I'll run my test. It'll say, did you want to save that previous test result? Nah, I really don't. So now we're running the test, and notice we don't get the error message because we're using the correct adapters. Now, this test passed. We see that our wire map passed, and when we look at our performance, we see that everything looks good. Now, in this case, our near-end crosstalk passed. We had a headroom of 4.3 dB. That's good. If we look at our insertion loss, one of the things that we find with our insertion loss is that we have very little loss across this link. It's a pretty short link. Now, our insertion loss never exceeds 3 dB of loss. As a result, we see that our return loss is informational. So that goes back to our 3 dB rule. And the 3 dB rule says that where insertion loss is less than 3 dB, we ignore return loss. So in this case, the link never exceeded 3 dB. All right, well, I'll tell you what, we come over and we look at that link. That is a pretty janky looking link right there. We'll come over and we'll just in case you need to see that a little bit better, let's zoom into that. So right there, we see that this link, that doesn't look so good right there. So why did it pass? Well, let's come back to the versive, and we are going to run a diagnostic test. So we'll share the versive here, and I'm going to go to my, let's go ahead and save that. I'll say save, and I'm going to type in a name here. I'm going to say mod 1 connector. All right. So let's come out to the home screen, and I'm going to go to Tools. Now, one of the things that we can do when it comes to running tests on here is we can run the diagnostics. We can force it to run diagnostics. This is where it's going to do the HD TDX and the HD TDR. So now it says generating diagnostics. Now, typically, these diagnostics aren't run unless we are marginal or fail. So what I'm going to do is I'm going to come in here and I'm going to take a look at my HD TDX analyzer. Now, what this does is this shows me my near-end crosstalk along the length of the link. And what we're looking for in this case, based on how long this link is, we would really like to see this near-end crosstalk less than 30% at the connectors. Now, if I go through each pair, I see here I'm at 22. That's good. Here I'm at 32. That's a little higher than I would care for it to be. There I'm at 0. Wow, that's impressive. Here I'm at 35. And here I'm at 30. So we're right in there, and our near-end crosstalk at our RJ45 jack isn't enough to cause this to fail. Now, here's the curious thing. We've got this really ugly connection over here, but notice that our near-end crosstalk right there doesn't look so bad. Why is that? That's because it's not included in the test measurement. So using the modified single connector permanent link test, we can pass bad looking connections like that. What we want is we want a test that's going to include that test measurement in the overall test. So let's look at how we do that. So we'll stop sharing here, and I'm going to come over here to the shelf, and I'm going to grab a Cat 6. You find one here. got lots of my Cat 6As, a Cat 6 patch cord adapter. So here we have a patch cord adapter. Now you'll notice that on that adapter, it says DSX PC6 Cat 6 patch cord adapter. Now, these adapters are specific to the category of cable we're testing. So in this case, I've got my Cat 6A patch cord adapter. I've got my Cat 6, and there's actually a Cat 5E as well. So if I'm depending on the cable I'm testing, I need to make sure that I'm using the correct patch cord adapter. So what we're going to do is we're going to remove the channel adapter right here from the remote. I'm going to plug in my patch cord adapter. Now, the big difference between the patch cord adapter and the channel adapter is that the patch cord adapter includes the near-end crosstalk in the test measurement. So I'll come over here, I'll plug my cable into that patch cord adapter. Now, let's go in and take a look at our Versiv over here. So I'll come back to my home screen, and I am going to add a new test. So I'll click on my Cat 6 test right here. I'll say New Test. I'm going to set my cable type to Cat 6 UUTP, and I'll come down here to my test limit. Now this time, I'm going to go to More. I'm going to go to TIA. I'm going to go to Cat 6. And if I come down here, what I find is, here is my Cat 6 MPTL. Now this is my modular plug terminated link. Now the big difference between the MPTL test and the modified single connector permanent link is that the MPTL is a BICSI standard, or it's a ISO. Let me rewind there. It is an ANSI TIA standard. So what that means is this is a standards-based test. BICSI test is not. The other piece is that we're using a patch cord adapter. So let's come back. I'll change my share. We'll look at this whole screen. And here's our MPTL test. Now, this is approved as part of TIA 568.2-D. What we see the big difference is between this and the modified single connector permanent link is that here we use a patch cord adapter. The patch cord adapter includes the near-end crosstalk in the test measurement. So in this case, we are going to look at the near-end crosstalk of that plug. So let's come back and let's do that. So in this case, I've got this set to MPTL. I'll hit save. I'll say use selected. And I'll run the test. I'll ignore that last result. Now I'm running the MPTL test. This is using that patch cord adapter to evaluate the near-end crosstalk of that plug. And now we see that we ran diagnostics. Now, when we ran this test using the channel adapter, our near-end crosstalk was 4-point-something dB. That was pretty good. Here we see our near-end crosstalk is negative. And if we go through each of our pairs, we see we're not performing very well. 4, 5, 7, 8 passed, but all the rest, well, 1, 2, 4, 5 passed. We see that some of our other pairs are failing, 3, 6, 7, 8. Now, if we come back, we go to our diagnostic, and we look at our HD TDX analyzer, we see that the majority of that near-end crosstalk is coming from that far end connection. So it's important to remember that when we're looking at the HD-TDR and the HD-TDX graphs, that the right-hand side is the main and the left-hand side is the remote. So here we are seeing some near-end crosstalk at the main end. We're seeing the majority of that crosstalk out here at the remote end, and it's caused by that cable right there. So this is an example of why we use that patch cord adapter. Now, somebody could say, I'm going to cheat the system. What I'm going to do is I'm going to come over here and I'm going to plug in my channel adapter. Because remember, when we did that permanent link test, even when we had the wrong adapter on there, it still let us continue. So watch this. We're going to hit test. And it comes up and it says the adapter on the remote tester is not compatible with the current reference or selected limit. Try another adapter or update the software. What this is telling us is I will not allow you to continue using that adapter because that would give us deceptive results. We were saying that we did the MPTL test, but we're not measuring the near-end crosstalk at the far end, which is part of doing that MPTL test. So you're saying, okay, Mike, what does a good connection look like? Well, let's come over here. So we're going to switch over here, and I'm going to unplug this ugly-looking connection right here. I'm going to come up to my patch panel right here. We're going to plug our permanent link adapter into one end of this MPTL link. I'll come over here, and this time we're going to do Cat6A. So I'll put my Cat6A patch cord adapter on my tester. And in this example, we're going to plug in a field terminated RJ45 connection. So let me stop sharing so we can get a better look at what I'm doing right there. So in this case, I've come in, I've connected the permanent link adapter to the patch panel, and here I have a field terminated connector. So instead of crimping on one of our little ice cube connectors right here, I've taken and use this field terminated connector. These provide better near-end crosstalk performance than the crimp-on connectors. So let's build a test and run it and see how that connector looks at the far end. So let's bring that versive back up again. We're going to go into our tests. I'm going to say new test. Here we're using Cat6A UUTP. We're going to set our test limit. We're going to go to more. We're going to go to TIA. We're going to go to Cat6A. And we're going to go down here to Cat6A MPTL plus PoE. I'll hit save. I'll select that test and I'll say use selected. And I'll hit test. So now we're doing an MPTL test on this link, and we're checking to see if it will support Cat6A and PoE. Ho, it passed. First thing we look at, we see that our wire map passed. We come over here to performance. We see that this link is 30.5 meters in length. We see that there's a check mark next to resistance. Because we selected plus PoE, resistance is included as part of this test. So I'll look at my pair unbalanced. We see that in this case, for this particular type of link, the only thing we're looking at is our loop resistance. Pair unbalanced is not a requirement on our MPTL test. We look at our insertion loss. We see that we've got good insertion loss performance. Here's our limit. Here's our loss values. Looks good. It's below the limit. That's fantastic. Our return loss looks good here. Our near-end crosstalk, well above that limit line. So in this case, we're able to say that this link is a Cat6a MPTL link, that we feel confident in the termination of that RJ45 plug at the far end. Now, you're saying, okay, Mike, let's see the diagnostics on that. So I'm going to come into Tools. I'm going to go to Diagnostics. Say, no, we're not going to save that. So now this time we're going to run the MPTL Cat6a test, but we're doing our diagnostics along with it so that we can see what our near-end crosstalk looks like at each of the different points along that link. I'm going to go to my HD TDX. Now, this looks really good. So when we come through, and I like to look at each pair individually, we see that this link is over 50 feet long. It's close, what was it, 30 meters? It's 150 feet or so. So what we're looking at is we're looking at values that are less than or equal to 35% in here. So in this case, 25 is great. That's at our patch panel end. Now, one advantage I have with having my tester right here is I can come in and I can tap on the screen. So let's come over here to the screen of the main, and I'm going to tap on the far end. I'm going to drag that mark over there. We're going to come right over here to that far end connection, and we're at 8.92. That is really good. That's our near end crosstalk for 1236. Now, one of the most challenging pair combinations that we run into is 3645. So let's come in here. Let's find 3645 right there. When we have an RJ45 connector, these two pairs are kind of wrapped around each other. So this particular pair combination tends to have the most near-end crosstalk. So if we come over and we look at that on here, we see that we're at 22.19. That is well within the range that we're looking for. So by using our patch cord adapter, we are able to measure that near-end crosstalk out there at that far connector. In many cases, more and more, we're seeing that MPTL is required in the testing specification. If it is required in the testing specification, then you need to make sure that you have at least one patch cord adapter for the category of cable you're testing, and that you're doing the MPTL test. I've seen a number of cases where people have done the modified single connector permanent link test instead. Their test results were rejected, and they had to go back and do that testing again. So if the contract calls for MPTL, make sure you're doing the MPTL test. You're using the patch cord adapter on the remote end. If the contract doesn't require MPTL, and you have the patch cord adapter, I would say make sure to do MPTL. Test the workmanship of those connectors at the far end, and then talk to the customer about the fact that you did the MPTL test to show that that workmanship was what we expect, that you are getting that full Cat6 or Cat6a all the way out there to the far end. So, short little we're in here at about half an hour. Little webcast on MPTL versus modified single connector permanent link, and why it is so important that we do that MPTL testing, especially if the contract calls for it.